Friends, myself B. Janalodi, Associate Professor in Electronics, with Shikshan Sanstha's Sadhguru Gadge Maharaj College. The topic I want to cover today is from electronics, and particularly it is the basic laws and theorems in electricity and electronics. Basic fundamental laws means Ohm's laws, Kirchhoffs laws, and some theorems I want to discuss. In electronics, electricity, one common fundamental term, frequently used term is a circuit. The circuit means, what is a circuit? Circuit is any interconnection of circuit element. Any interconnection of elements such as resistor, capacitor, sources, load, whatever it may be, any interconnection for particular purpose, it is known as a circuit. If without any purpose, if anybody try to connect these components, we can't consider it as a circuit. Circuit means there should be some purpose, connect different components together, it is the circuit. For example, these are the circuits. Here, in the first circuit, DC battery, we have connected 10 volt DC battery. This is the network, and RL, it is the load. RL means certain, it is a bulb or a LED bulb or speaker, whatever, where the electrical energy is utilized. So, to have, suppose it is an electrical bulb, that means we have connected this circuit in order to get the light from electrical energy. So, for particular purpose, such type of component, if we connect together, it is a circuit. This is also circuit. Here AC source we have used, and this is a load, fan, bulb or heater, whatever it may be. We have connected it with the wire. So, this is the circuit. And in the circuit, the fundamental three important parts are, any circuit, three parts are, one is the source which provides electrical energy, another is load, it utilizes electrical energy, and another is the part is the network or wires. It is used to transport the electrical energy from source to load. Proper converting the electrical energy for transmission, network is also important. Now, in the circuit, fault finding, designing, similarly, analysis is again important. Circuit analysis means what? Circuit analysis means calculate current in the circuit. If we have connected the circuit, what is the current in the circuit? What is the power dissipated in the load? Or what is the power absorbed from source? What is the power loss in the circuit? So, calculate these factors, voltages across different components, current in the different paths or in the network, or power dissipated. This calculation means analysis. Now, to analysis, for analysis purpose, in electricity, in electronics, the fundamental laws are used. One very important law is Ohm's law. It is a standard law, very useful. Particularly 99% for analysis calculation we use in the circuit Ohm's law. What is Ohm's law? It states that when the physical state of conductor, that means resistor, remains same, if the resistor is constant, the current is proportional to applied voltage. Or for constant resistor, I is proportional to V. For electronics, for BCS or computer student is concerned, this nature of the law, phi is equal to IR, voltage equal to current into value of resistance, or current in the resistor equal to I is equal to phi divided by R. This formula we must know, we must utilize. I is equal to voltage divided by total resistance, or V is equal to I into R. This is the format of the Ohm's law. How we use? We use, suppose this is the circuit, and suppose this voltage V is of 10 volt. V is the voltage and it is of 10 volt. R1, suppose it is a 10 ohm resistor. So this is a 10 ohm. And suppose this is a 90 ohm resistor. Okay. So we can calculate current in the circuit. We can calculate current in the circuit. I is equal to V divided by R, voltage divided by RT, I can say total resistance. So total resistance V is voltage 10 volt. Total resistance is two resistors are series. Suppose 10 ohm plus 19 ohm. So 10 divided by 100, that is 0.1 ampere is the current. So using the Ohm's law, we can easily calculate the current. Even voltage drop across this component. What is the drop across this component? Use this for phi is equal to IR. So I current is there 0.1 ampere into 10 volt. That means 1 volt. So voltage across R1, I can say phi R1 is equal to 0.1 into 10. That is 1 volt. So 1 volt drop is there. And this voltage drop, its polarity is positive towards the entry of current. So current I, its direction is like this. Current I, direction is. So entry of the current, this point becomes positive, this becomes negative. Similarly, this becomes positive. Voltage across R2 is equal to current into this resistor. So it becomes 9 volt. So in this way, we easily calculate for us. Sometimes what happens, source having some internal resistance and it is given in the bracket. Suppose the source resistance is again 2 ohm, internal resistance is. Then while calculating current, this 2 ohm must be considered. So 10 volt divided by 10 plus 19 plus 2. We must calculate current in this way. So in this way, we calculate current, voltage drop, even power. Suppose this resistance R2. Its voltage across it is a 9 volt. Okay, we have calculated 9 volt voltage, and current in it is a 0.1 ampere. So power across R2 is equal to voltage into current. So power, similarly power also we can calculate. So in divided by total resistance of the circuit. Suppose V is the voltage, then if it is a 10 volt or 5 volt, V is the voltage. Then V divided by total resistance. Total resistance, how to calculate? Here R2 and R3 are in series. So these are added together. So V divided by total resistance means this R1, it is a parallel with combination of R2 and R3 in series. So R2, R3 parallel to R1. This is the total resistance. So in this way, easily we can calculate the current in the circuit, then power in the circuit. So Ohm's law becomes very useful in the circuit analysis. But sometimes what happens, the circuits are rather complicated. Ohm's law we can use, but it becomes the tedious task. So instead of Ohm's law, another important law in electricity, in electronics, and this is the Kirchhoffs law. Kirchhoffs law is also very useful to analyze the circuit. But note that Kirchhoffs law is simply modification in the Ohm's law. Modification in those. So Kirchhoffs actually he contributed 2 laws in the electricity. One is a voltage law and another is the current law. In any circuit, there is an interconnection of circuit element. So automatically it gives different loops, different nodes, junctions, etc. So in this circuit, this is the first loop, this is the one loop. This is another loop, this is third loop. Again this complete, it is any closed path is the loop. And when the 2 or more paths, when 2 or more elements comes together, it is known as a node or junction. So nodes are there, different closed loops are there. So Kirchhoffs law, this is Kirchhoffs law. Kirchhoffs given these 2 laws for. One law it is given for the loop, and another law it is given for the junction analysis. So Kirchhoffs voltage law and Kirchhoffs current law, these are the 2 laws. The first law is the Kirchhoffs voltage law. Kirchhoffs voltage law, it states that for any closed path or the loop, the net voltage in the loop is always equal to 0, or algebraic sum of voltage in the voltages in the closed path, it is always equal to 0. So now in this circuit, this is a closed path, this completes one loop, this is again closed path, this is another loop, and even the outside circuit, it is also one loop. So for any loop, we can write the equation using Kirchhoffs voltage law. It states that in any loop, algebraic sum of voltage is always equal to 0. Means sum of voltages with direction, it is important. The voltages with direction, the sum of these voltages, and it is equal to 0. This is the Kirchhoffs voltage law. For example, for this loop, how we can suppose this E is the voltage, applied voltage, and its direction is like this. and voltage across R1 is IR1. Voltage across R2 is I into R2. So net voltage in this loop or algebraic sum of voltages in this loop is simply E minus IR1 minus IR2, and this is always equal to 0. So I can say summation of IR in the closed loop is always equal to 0. This is the Kirchhoffs voltage law. Similarly, there is a Kirchhoffs current law. We can write. The current law, it is for node or junction. In any circuit, if there are number of paths and this path comes to, it is known as a node or junction. For any node or junction, net current or algebraic sum of current is always equal to 0. It is a Kirchhoffs current law. Now this is, suppose this is a junction point, any junction point. Here different currents are I1, I2, I3, these are incoming currents, and I5 and I4, these are outgoing currents. If we consider incoming current as a positive, then outgoing current, these are negative. So net sum of current is I1 plus I2 plus I3 minus I4 because it is outgoing, minus I5, it is also outgoing. So net current is equal to 0. So sum of current in the network junction is always equal to 0. This is the Kirchhoffs current law. So we can use any law as convenient. Ohm's law, Kirchhoffs current law, KCL Kirchhoffs current law, Kirchhoffs voltage law in order to analyze the circuit, and these are sufficient. I think these three laws, if we know, we can analyze the circuit easily. But sometimes what happens, circuits are too complicated, rather complicated, consist of 20, 40 components, and to analyze such circuit using this basic law, it is not impossible. It is possible, no doubt, but it requires large time. It becomes a tedious task, and that's why theorems are also used. Note that theorems are directly we can't use for calculation, but using the theorems, complicated network we simplify first, and the simplified network then we can analyze with our fundamental laws. So there are different theorems also. These theorems are, so this is the complicated network. We can, no doubt, we can analyze it with Ohm's law or Kirchhoffs law, we can apply, but it becomes tedious task, and that's why network theorems are used. And these theorems are Thevenin's theorem, Norton theorem, superposition theorem, maximum power theorem, Millman's theorem. These are important theorems. We will study these theorems. Thevenin's theorem. Note that when electronic circuit is more complicated, then theorems are used first to simplify the network, to obtain simple equivalent network for the complicated network, and once simplified network is available, then we can easily calculate the current, voltage, power using Ohm's or Kirchhoffs law. So first theorem is Thevenin's theorem. Now Thevenin's theorem states that any complicated network we can convert into simple network which consists only two components. Let us see. This is a complicated network. It may include impedances, resistances, number of resistances, impedances. This is the complicated network. It gives power to the load. Now this is the complicated network, and if we try to calculate what is the power delivered to load, it becomes difficult for complicated. Then according to Thevenin's theorem, this complicated network is converted into simple equivalent network which consists only two components. Voltage source known as a VTH, Thevenin voltage, and RTH means Thevenin resistance. So any complicated network, it consists thousands or hundreds of components. We easily convert into two component circuit, and once it becomes simplified, apply the Ohm's law to calculate the current. This is Thevenin's theorem. So Thevenin's theorem is used to obtain complicated network into simple, convert complicated network into simple. So theorems, any theorem we use to simplify the network. It states that any two-terminal linear network containing energy sources and impedances, it is the information of the network. The first paragraph, the first sentence is about network. This type of network, any two-terminal, that means the network should have two terminals. When we disconnect the load, there are only two terminals. So it is a two-terminal network. Any two-terminal linear network containing energy sources and impedances can be replaced by equivalent circuit, can be replaced by equivalent network which consists VTH in series with RTH. This is the Thevenin's theorem. Note that only conversion is not important. A complicated is converted into two components. This is not important. But this simple network must be equivalent to this network. And how to verify it? This complicated network delivers power to the load. And the same power must be delivered by the simple network also. Then we can say the simple network is equivalent to complicated network. Both networks are equivalent if provides same power for same load. Then these are equivalent. So the Thevenin's theorem is used to convert complicated network into simple equivalent network. Let us see the example of Thevenin's theorem. Thevenin voltage VTH is open circuit voltage. So Thevenin's theorem is VTH, how to calculate VTH? It is open circuit voltage. That means open the load. These are the two terminals. And voltage across two terminals is VTH. And then see the total resistance of the network from load side. It is the resistance of the network. So VTH is the open circuit voltage and RTH is the resistance measured between terminals of the network. If we calculate these two factors, we can easily obtain Thevenin equivalent circuit. So this is our problem. This is the network. It consists of 5 components. How to apply Thevenin's theorem? For Thevenin's theorem, to convert this into equivalent circuit, first calculate VTH. For VTH, open this load. And now circuit becomes like this. This 10 volt, 2 ohm, 2 ohm, 4 ohm. This is the open two terminal. Now voltage at two terminals, easily we can calculate. Voltage at these two terminals means voltage across 2 ohms. Note that this is a 4 ohm resistance. This is there, but it carries no current. That's why there is a no drop across it. So what is VTH? VTH means voltage across 2 volt. According to potential divider law, 2 divided by 2 plus 2. 2 divided by 2 plus is 2 ohm. This resistance divided by remaining total resistance 2 plus 2. 2 divided by 2 plus 2, that is into the applied voltage 10 volt. So it gives 5 volt. Suppose this cell consists internal resistance. Suppose it is of 2 ohm. Then we must include internal resistance also. So how to calculate voltage? Voltage across 2 ohm resistance is 2 divided by 2 plus 2 plus internal resistance. 2 divided by 2 plus 2 plus 2 into 10 volt. Then it gives VTH. So however, calculate first VTH. This is the half part. Now calculate RTH. RTH means again open this resistance, load resistance, and remove the source also, because we want resistance only. So eliminate the source. It is a short. If the internal resistance of this source is there, include this internal resistance. Otherwise, simply it short. And the resistance, resistance between two terminals is now. From this point to this point, calculate total resistance. Here, 4 ohm resistance, it is in series with 2 plus 2. So, total resistance is equal to 4 ohm plus 2 parallel 2. 2 parallel 2 is 1, because when 2 parallel resistors are there, then total resistance is R1, R2 divided by R1 plus R2. So, 2 into 2 divided by 2 plus 2 means that is equal to 1 ohm. So, 4 plus 1, it is 5 ohm. And now, the given network is converted into simple equivalent network. This VTH 5 volt, RTH 5 ohm, and original load now it connected. Now we can easily calculate the current using Ohm's law. I is equal to voltage divided by total resistance. So it is the current in the circuit. So using Thevenin's theorem, we can easily calculate the current. In this circuit also we use Ohm's law. Ohm's law is, according to this law, again current is equal to voltage. Another important theorem, that is Norton's theorem. Norton's theorem is simply replica of Thevenin's theorem. What is the difference in Norton's theorem? Same. Any complicated network we can convert into equivalent network. But the Norton equivalent network consists current source in parallel with resistance. And what is Thevenin we saw? Thevenin consists voltage source in series with resistance, and Norton consists current source in parallel with resistance. So Norton's theorem is same as the Thevenin's theorem. Again, we can state Norton theorem as state that any two-terminal linear network containing energy sources and impedances, it is information of this network. It can be replaced by an equivalent circuit which consists current source in parallel with resistance. This is a Norton equation. Now what is our remaining part? We must calculate iron, we must calculate Rn. We can easily obtain Norton equivalent circuit also. Iron means short circuit at the load. So if your network is like this is the network, and we want the Norton equivalent circuit. Suppose this is the Rn. Norton current Iron is obtained by short circuiting this load. Short the load. And what is the current? Measure it. And Norton resistance means open the load and observe the resistance between two terminals. Similar to Thevenin, Norton resistance is also calculated in the same way. Iron, connect Rn, this becomes Norton equivalent circuit, and easily calculate the current flow. Easily calculate. Again, let us see the same example. This is the network, and we obtain its Norton equivalent circuit. So for this network, Norton equivalent circuit, obtaining Norton means calculate Iron and R. Iron means short this load. When we short this load, the circuit becomes like this. Now what is the current Iron? Iron, calculate the current is equal to voltage divided by total resistance. So Iron, while calculating Iron, first we must calculate net current I. So I is equal to 10 volt divided by 2 ohm plus 2 parallel 4. So I is equal to 10 divided by 2 plus 2 parallel 4. This is the current I. And after that, once we get I get divided again into two parts. One part going through 2 ohm, another part going to 4 ohm, that is iron. So current iron is equal to I into opposite resistance 2 ohm divided by total resistance 2 plus 4. So in this way, iron is calculated. Iron means short. So once iron is calculated, now calculate Rn. Rn means same way. Open this load, measure the resistance while eliminating the source. So Rn is the resistance appearing here. It is a 4 ohm parallel to 2 ohm series with 2 ohm parallel 2 ohm. So it becomes again 4 plus 2 parallel 2, and that is equal to Rn. So Rn is equal to 4 plus 1, and it is again 5 ohm. So connect these two values I and Rn, it becomes a simple network. So instead of complicated network, now analyze the simple network. This is an easy way to obtain the current using Norton's theorem also. So these two theorems are very important out of these 4-5 networks to simplify the network. Now next theorem is this is superposition theorem. This is also very useful. What happens sometimes, the network consists number of sources. Source 1, source 2, source 3, and then it becomes difficult how to calculate current. In that case, such cases, the superposition theorem is very useful. It states that doesn't matter how many sources are there. Consider each source independent. That means suppose this is the network, it consists V1 and V2. While functioning V1, appearance of V2 is not affecting anyway. So when V1 sends current, V2 is present or absent, there is no problem. So calculate current by considering V1 independently, calculate current by considering V2 independently, finally add these two currents. This is the way to calculating current. That means simply, if there are number of voltage source, energy source acting simultaneously in the network, each one work independently. This is the superposition theorem. In this network, while calculating the current, first consider only V1 and remove this V2. Secondly, consider only V2, remove V1. calculate current here, calculate currents here, and simply finally add these currents. This is the superposition theorem. And final theorem is maximum power transfer theorem. Maximum power transfer theorem, particularly it is very useful in audio circuits. That is, when for audio amplifier, if we connect the speakers are of different values, 4 ohm speaker, 8 ohm speaker, 15 or 16 ohms. Which speaker is proper to get maximum sound, proper sound? This calculation is done with the help of maximum power. This is the simple theorem. This gives idea about matching. This is the network. Suppose this is the amplifier and this is your speaker. When this amplifier gives maximum power to speaker, if amplifier resistance is equal to resistance of speaker, technically I can say maximum power transfer theorem, it states that a network delivers maximum power to load if resistance of network is equal to resistance of load. Both must be same. Its resistance and its value, both must be. Or I can say the load can absorb, this load can absorb maximum power from network if its resistance equal to resistance of network. Anyway, simply when two resistance are same, if there is a proper matching, which gives the energy, the network gives the energy. Which absorbs energy, the load absorbs energy. So network and load, if there is a proper matching, then there will be maximum transfer of energy. This is maximum transfer theorem. Technically we say that any two-terminal linear network can deliver maximum power to load if its resistance equal to resistance of load. Or alternatively, any load can absorb maximum power if its value equal to resistance of network. This is maximum power transfer. So these are the theorems and these are the laws we will use frequently to analyze the circuit in electricity, in electronics.